All right, everyone. What's up? In today's video, we're going to talk about evaluating trig functions now that we have the unit circle completely filled out. So you want to become besties with your unit circle. You want to know degrees. You want to know the radian equivalent of the degree measures. You also want to know the coordinates and also be familiar with where certain parts of the unit circle exist, like specifically speaking in terms of like quadrants and things like that. So we're going to get started. We're going to evaluate a ton of trig functions. So get your notebooks ready and follow along with me. Also, make sure you have your filled in unit circles. You should have them by now. If not, go ahead and fill one out really quick because we are going to need it. Let's dive in. All right, so the first thing we're going to do is we're going to just start off by evaluating the functions for the given angle. So I'm going to give you an angle up here at the top. You'll notice it will say theta is equal to pi over 3. So we're talking about pi over 3 radians, aka 60 degrees. And I want to find sine, cosine, tangent, cosecant, secant, and cotangent for pi over 3 degrees or pi over 3 radians. So let's go ahead and get it started. The most important thing that you're going to need for this is you're going to need to know where in the heck and bob is pi over 3 located. So if you want, you might even want to note like this is 60 degrees. That's going to be in quadrant 1. And so as you actually end up going through, voila, here's our unit circle. Look at this movie magic right here. We're talking about this spot right here. Pi over 3 is the same as 60 degrees. It's in quadrant 1. And this is going to be 1/2 root 3 over 2. That's our coordinates. Now, I don't know if you remember, but cosine comes first, and then sine is going to come second as far as our coordinates go. So once we have our unit circle, it's going to be really easy to begin to evaluate these functions. So sine of pi over 3, meaning sine of this particular angle, pi over 3, is going to give us the coordinate root 3 over 2. And if we know sine, then we know it's reciprocal cosecant, right? We're just going to flip root 3 over 2, and we'll have 2 over square root of 3. But we can't have a radical in the denominator. You're going to need to rationalize. So we're going to have 2 root 3 over 3. Lovely. Now we need cosine of pi over 3, or the cosine coordinate for pi over 3 radians, 60 degrees. That's going to be 1/2. And if we know cosine, we know it's reciprocal secant, which is just going to be 2 over 1 or just 2. And lastly, tangent. Tangent is kind of the hard one. Tangent, if we're going back to SOHCAHTOA, that's opposite over adjacent, right? So if I did this is going to be kind of a unnecessary long explanation. But if I created a triangle, right, dropped a perpendicular, this is the angle, opposite side, adjacent, hypotenuse is always equal to 1 in our unit circle. The opposite side, you can see that this is the y, and the adjacent side is the x. So really, this is going to, tangent is y over x, or the y coordinate, aka sine, divided by cosine, or divided by y, or x, which is root 3 over 2 divided by 1/2, which is a double-decker fraction. We definitely do not want to have double-decker fractions. Number one, they hurt our head. They're disgusting to look at. Oh my God, no. So to simplify this process, we're going to keep the top numerator. We're going to change it from division. Change it from division, and then flip the denominator and cause it to become multiplication. So we're going to keep rad 3 over 2. We're going to multiply instead of divide. And instead of multiplying by 1/2, we're going to multiply by 2 over 1, the reciprocal. This is keep, change, flip. Notice that those cancel out, and you'll just have the square root of 3 over 1. Now, if we know tangent, excuse me, gross. We also know cotangent, which is the reciprocal of tangent. So we're going to take our final solution, square root of 3 over 1, and have 1 over the square root of 3. Again, we're going to have to rationalize our denominator. So this is going to come root 3 over 3 as our final. Now, if the key change flip was a little tricky for you, never fear. We're going to continue to do it over and over and over again. Practice makes perfect, right? So 7 pi over 6. Take a sec, look at your unit circle. Where in the heck is 7 pi over 6? It is going to be in quadrant 3, and that's the equivalent to 210 degrees. So let me pull that up. Boom. 7 pi over 6 right here, 210 degrees. We've got this coordinate, right? Once we've got this coordinate, remember it's cosine, comma, sine, because C comes before S in the alphabet. So does X before Y. So we're looking at 7 pi over 6. Sine is negative 1/2. Cosine is negative, square root of 3 over 2. And tangent, remember, that's going to be y over x. Or you can think of it as sine over cosine. That's going to be negative 1/2. Keep. Change it to division. And flip. And I kind of already set us up here. So we're going to do this one first and then this one second in this order that I've set up the problem. So we're going to keep negative 1/2. We're going to change it to multiplication, and we're going to flip cosine and multiply by that. So 2 over the square root of 3, and there's a negative down here. Notice that those 2's will cross cancel, and you'll have negative 1 over negative square root of 3, or 1 over the square root of 3. Rationalize that bad boy. We'll have rad 3 over 3 for tangent. Now, once we know sine and cosine, and honestly tangent for that matter, we can find cosecant, secant, and cotangent. So cosecant is going to be the reciprocal of sine, so that will be negative 2 over 1, or just negative 2. Secant will be the reciprocal of cosine, so negative 2 over square root of 3. Rationalize that denominator. We're going to have negative 2 square root of 3 over 3 as our final solution. And cotangent, something you want to be super careful about is just make your life easier and take the reciprocal before you rationalize. If you don't, it's not the end of the world. You're just making a little bit more work for yourself. But if I take the reciprocal of this right here, it's going to be the square root of 3 over 1, or just the square root of 3. Now, if for whatever reason you accidentally took this guy, right? So you have 3 divided by the square root of 3. That would be the reciprocal. If you rationalize that denominator, you'll have 3 square root of 3 over 3. Look, those guys cancel, leaving you with this. So it's not the end of the world if you forget, but just know that it's easier before you rationalize the denominator. Take your reciprocal trig function and you'll be able to get it easy peasy lemon squeezy. Let's move on. We got a lot to do. 3 pi over 4. Where in the world is 3 pi over 4? Take a look at your unit circle. 3 pi over 4. That is in quadrant 2, my dudes. And something I want you to get familiar with is if it has 4 in the bottom, that means it's a 45 degree. And the 45 degree angles are the easiest to remember because those coordinates are root 2 over 2, root 2 over 2. Okay? And since it's in quadrant 2, x is in the negative direction, but y is in the positive. So we're going to have our coordinate is negative root 2 over 2, root 2 over 2. And sure enough, if we look right here, boom, that's exactly what we've got. So this is kind of exciting. Remember, it's cosine, comma, sine. Cosine, comma, sine. So sine coordinate is positive root 2 over 2. Cosine is negative root 2 over 2. And tangent is going to be y over x. Y over x, or sine over cosine. Remember, we're going to keep, change, flip it. So sine root 2 over 2, change to multiplication, flip, and we're going to take the reciprocal of cosine, 2 over negative square root of 2. If we do this, these 2's will cancel, and so will these, actually, and we'll be left with just negative 1. So tangent, usually for the 45-degree angles, all of these guys over here, they're either going to be positive 1 or negative 1 because you're really dividing by the same value, just either with a negative sign or not, which is kind of fun. Moving on to our reciprocal functions, cosecant, right? We're going to take the reciprocal of sine, so that's 2 over the square root of 2. Don't forget to rationalize. You'll have 2 square root of 2 over 2, and that just leaves you with the square root of 2 for cosecant. Secant is going to be the same idea, taking the reciprocal of cosine, so you have 2 over negative square root of 2, kind of the same idea. 2 square root of 2 over negative 2. These guys will cancel, and you'll just be left with negative square root of 2 for secant. And cotangent is going to be the reciprocal of tangent. Now, since this is negative 1, okay, like tangent was negative 1, it's really negative 1 over 1. So we can take cotangent, the reciprocal, 1 over negative 1. So cotangent is still just negative 1. Kind of weird, but not really. And I swear, as we continue to go through these problems, we are going to get better. It's all about understanding where things are on the unit circle and being able to find these values fairly quickly. 5 pi over 3. Which quadrant is 5 pi over 3 existing? Well, it's not going to be in quadrant 1, that's for sure. Not going to be in quadrant 2 or 3. It's actually going to be in quadrant 4. And remember, in quadrant 4, x is positive, but y is negative. So, and if it's a 5 pi over 3, if it's over 3, that means it's going to be one of the 60-degree angle measures. That's the reference angle. So we can use that. We can use, if it's a 60-degree reference angle, that means the coordinate is 1/2 root 3 over 2, and we'll just have to change the sign since it is in quadrant 4. And if you look here, 5 pi over 3, it's 1/2 negative root 3 over 2, just as I was explaining. So sine, that's the y coordinate, negative root 3 over 2. Cosine, that's the x coordinate, 1/2. Tangent, that's going to be sine divided by cosine, or really, if you want to go the keep, change, flip, you can really do sine times 1 over cosine, or the reciprocal of cosine. You could even write secant. That might even be kind of funner to write here. 1 over cosine. The reciprocal of cosine is going to be secant, and we already can have secant filled in. So to find tangent, we're going to take sine, negative rad 3 over 2. Multiply it by the reciprocal of cosine, 2 over 1. That will cancel out, and we will end up with negative rad 3. Nice. Now for our reciprocal functions. Cosecant, that's going to be 2 over negative rad 3. Rationalize that denominator. You'll have 2 square root of 3 over negative 3. Secant is going to be 2 over 1, or just 2. And cotangent, remember, you can just take it off of negative radical 3 over 1. So 1 over negative square root of 3 could be cotangent. You can take it off the simplified version. And then we got to rationalize that denominator. So that's going to be square root of 3 over negative 3. Or negative square root of 3 over 3. Doesn't matter where the negative falls. Are you guys feeling okay on this? Let's keep it going. So now you're starting to see why it's important to have the unit circle filled out or to have these values memorized. If you have not yet memorized your unit circle, make sure you do. It makes our life so much easier, especially when it comes to evaluating. And I'm purposefully doing this in radians first because I know we're very comfortable with degrees, but radians is representing the exact same thing. All right. What happens if I ask you to go negative 2 pi over 3? So switching the direction. Normally, if we were going to go 2 pi over 3, that's over here in quadrant 2. You would go 120 degrees, that's that way. That's positive 2 pi over 3, right? Or positive 160. But I'm asking for negative 2 pi over 3. So again, we always start here. Here's negative 90. So it's going to be down here. Negative 2 pi over 3. It's actually something you might notice, which I think is really cool, is it's this point reflected right down there. So if we look at our unit circle, right here's 2 pi over 3 right here. So negative 2 pi over 3. I'm going to follow this all the way down. That's going to be this coordinate. That's going to be 4 pi over 3, and that's going to be 240. And let me prove that to you. So remember, a negative angle just means you're going in the negative direction. So I don't want to do that in that. I want to do it in a pen. If you normally have 360 degrees, 2 pi, and you take away 2 pi over 3, okay, you're going to need a common denominator to do this. 2 times 3 gives you 6 pi over 3. Take away 2 pi over 3. Would you look at that? 4 pi over 3 is what we're talking about. And if you look right here, that's exactly what that says, 4 pi over 3. So we're really saying theta, if you want to do a positive angle, is 4 pi over 3. They are the same thing. They're actually coterminal. They end in the exact same spot. So we're going to find sine, which is the y-coordinate, negative rad 3 over 2. Cosine is the x-coordinate, negative 1/2. They're both negative because it's in quadrant 3. And tangent, remember that's going to be sine, negative rad 3 over 2, times the reciprocal of cosine, 2 over 1. You're going to have negative square root of 3. It's kind of like the last example. Cosecant is the reciprocal of sine. So you have 2 over the square root of negative square root of 3. Rationalize that denominator. You have 2 square root 3 over negative 3. Your negative symbol can go anywhere. It can go in the numerator. It can go in the denominator. It can go out in front. It does not matter. For space, I'm just going to leave it on the denominator. Secant's going to be the reciprocal of cosine, so that's going to be 2 over negative 1 or negative 2. And cotangent is going to be the reciprocal of tangent, so it's going to be 1 over negative square root of 3. Rationalize this denominator. You're going to have square root of 3 over 3. And don't forget that negative here. I'll just put it on the outside. Let's try another negative angle, negative pi over 2. So if we think about our unit circle, we know that this is 0 and 2 pi. This guy right here is pi. This is regular pi over 2. And so in the positive direction, it's that way. However, the negative direction, negative pi over 2, lands us at 3 pi over 2. And these points, these are called quadrantal points. And those coordinates are with 0 and 1. So we're going to look at this point over here, 3 pi over 2, 0, comma, negative 1. Remember, again, all of your coordinates are always going to be represented by cosine, comma, sine. And that's just because cosine happened to be that side length, the x side length for whatever triangle we were drawing, and sine happened to always be the y side length for whatever triangle we were drawing when we were first coming up with our coordinates. I'm drawing our special right triangles. So sine is going to be the y coordinate, negative 1. Cosine is going to be 0. Tangent is sine over cosine, or y over x, whatever works best for you. Oh my goodness. Right? So sine was negative 1 over cosine 0. And this is a big no-no. This is undefined. You can never, ever, 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 ever in a million years divide by 0. So don't even think about starting now. We can't divide by 0 because it doesn't make sense to divide by nothing. but also really, really, excuse me, really weird things begin to happen in mathematics when you divide by 0. It's never consistent. Sometimes there's holes, sometimes there's asymptotes, sometimes your function behaves really bizarrely. So there's a lot of just continuities, and since there's no like definitive answer mathematically, we just say that it's undefined. As a matter of fact, if you try and divide by 0 in your calculator, it will say error. So it's just one of those things that we cannot do. We're not definitively sure what happens, so we're just saying we don't know. It's undefined at that particular value. Cosecant. All right, it's going to be the reciprocal of sine. This is really, if it helps you out here, divided by 1. So this would be 1 over -1. Still just -1. Again, this is over 1 as well. This becomes 1 over 0, which is, again, undefined. And cotangent, don't try to reciprocate undefined. Go back to the last known value that we had and take 0 over -1. And it is okay to have 0 on top. That's just equal to 0. But you cannot not divide by 0. So cotangent of -π/2 or cotangent of 3π/2 is equal to 0. What happens when we start transitioning to degrees? Because I could ask you degrees or radians for any of these. So 180 degrees, if we think about that, that's right here. That's that point x is -1, y is 0. We have those coordinates. Look right here. Sine is the y, 0. Cosine is x, -1. And tangent is y over x. Remember, it is okay to have 0 on top, so that's just equal to 0. If we were going to find the reciprocal, 1 over 0, that is undefined, so cosecant does not exist at 180 degrees. We'll see that when we go to finally graph these things or take a look at what the graphs look like. This will make a lot of sense. There's a very special attribute that happens when we have an undefined part of our graph or our function. When we go and reciprocate cosine, we're going to have 1 over -1. That's just -1 for secant. And cotangent, we're going to reciprocate 0 over -1. So we'll have -1 over 0. And again, we cannot divide by 0. It's undefined. 60 degrees. 60 degrees, first of all, that's in quadrant 1. From here, it's going to be the one closest to 90 degrees. So that's going to be 1/2 √3 over 2. I use the trick for reading a clock to remember that guy. And would you look at that right here? So once we know that, once we have our coordinate, it's really easy to determine what this is going to be. Sine is going to be √3 over 2. Cosine is going to be 1/2. I can do secant and cosecant right away. This is going to be 2 over 1 or just 2. Cosecant is going to be 2 over the square root of 3. Rationalizing that denominator, you're going to have 2 square root of 3 over 3. And tangent, remember that's sine divided by cosine or multiplied by the reciprocal. That just becomes the square root of 3 for tangent. And cotangent will be 1 over the square root of 3. But we have to rationalize that. So you'll have rad 3 over 3. 315 degrees. All right, that's obviously going to be in quadrant 4. And pro tip, if the angle ends in 5, that's one of those 45-degree angles. It's right in the middle, which means the coordinate is √2 over 2, √2 over 2. Since it's in quadrant 4, if we look at it, right, that means x is positive, but y is negative. So I just throw a negative onto that baby. And lo and behold, 315 degrees is precisely that. So sine, -√2 over 2. It's always the y coordinate. Cosine is the x coordinate. Tangent is sine divided by cosine. So negative root 2 over 2 times the reciprocal of cosine, 2 over square root of 2. These guys will cancel. I guess I'll show all of the work on this one. Negative root 2 over root 2. These guys cancel, leaving you with just negative 1. You could have also done that, but whatever, float your boat. Cosecant is going to be the reciprocal, so 2 over negative rad 2. Rationalize that denominator. You have 2 square root of 2 over negative 2. That just becomes negative radical 2. Secant, kind of the same story. It's just there's no negative. So that's 2 over the square root of 2. Rationalize gives you 2 square root of 2 over 2. Or just positive square root of 2. And cotangent is the reciprocal of tangent. That's going to be 1 over negative 1. Or also negative 1. I hope you're starting to see why knowing where these degrees and radians on your unit circle is super duper important. 210 degrees. That is going to be in quadrant 3 because it's less than 270 but greater than 180. I always think this is 180. This is 270. It's going to be closer to 180, which means that guy is going to form a its reference angle is going to be 30 degrees since it's closer to 180. Well, 180 plus 30 is 210. And if the 30 degree angle in quadrant 1 that has the coordinate root 3 over 2 1/2, and since it's in quadrant 3, both of them are negative. Look at this. 210 degrees, which is right here, 7 pi over 6. Look, negative root 3 over 2, negative 1/2. So really, remembering that first quadrant and those coordinates is so important. It helps so much when it comes to evaluating, especially if you're not 100% on where things are in the unit circle yet. Knowing quadrant 1 is so vital, so important. Let's evaluate all 6 trig functions. Let me just erase, I don't really need this piece right here right now. It's kind of getting in the way here. I'm going to change my color up. You know what? Why not? Sine is the y-coordinate, negative 1/2. Cosine is the x-coordinate, negative root 3 over 2. Tangent is sine divided by cosine, or sine times the reciprocal of cosine. Those 2's are going to cancel. You can even think the negatives are going to cancel. You'll have 1 over the square root of 3. Rationalize that denominator. You'll have root 3 over 3, baby. Awesome. Now let's find all of the reciprocals. 2 over negative 1, that's just negative 2. 2 over negative square root of 3. Rationalize that. You'll have 2 square root of 3 over negative 3. And cotangent, you'll have 3 over the square root of 3. Rationalize will be 3 rad 3 over 3. Oops, I did what I said earlier. It's just the square root of 3. Remember earlier I said you can just take this one and take the reciprocal, and the reciprocal of that is the square root of 3. I forgot, and I just went off of my final answer. But like I said previously, it will still work out to be the same. All right, let's go. Let's do another example. The more we do, the better we get at it. Practice makes perfect, y'all. Ooh, negative 30 degrees. All right, let's visualize this. Negative 30 degrees. Instead of going up 30 degrees positively, you're going to go down 30 degrees. You can visualize that as 360, take away 30, and that's going to give you 330 degrees. So you can visualize it that way. Looking, that's obviously in quadrant 4. That's going to be root 3 over 2 1/2, but with the different signs. And if we look right here, 330, we've got all of this information right here. We're looking at this, that angle. Sine, negative 1/2. Cosine, positive root 3 over 2. Tangent is negative sine divided by cosine, or multiplied by its reciprocal, multiplied by cosine's reciprocal. Keep, change, flip. So we don't have those double-decker fractions. You have negative 1 over the square root of 3 or negative square root of, hey man, negative square root of 3 over 3 for tangent. Now it's time to take our reciprocal. So this is going to be 2 over negative 1 or just negative 2 for cosecant. Take the reciprocal. Same thing for secant. I have 2 over square root of 3. But we do not leave our answers with radicals in the denominator. No, sirree, Bob. We rationalize it every time. Multiply by square root of 3 over square root of 3, and you get 2 rad 3 over 3. And lastly, cotangent. I can reciprocate this guy if I want, and I will have square root of 3 over negative 1 or negative square root of 3. However, if I forgot for whatever reason and I accidentally did this one, I would have 3 over negative radical 3. I would have had to rationalize my denominator. I would have 3 radical 3 over negative 3. And would you look at that? I end up with negative radical 3. So whatever way your brain remembers it, it works out to get the same solution for cotangent. I feel like we're getting better at this, yeah? Yes, no, maybe so. Negative 135 degrees. Negative 135 degrees. So I want to notice that positive 135 is over here, right? Oops, I wanted to highlight that. Okay, positive 135 is up here. That's going from here all the way over here. That's positive 135. If I was to do the opposite, start here and go down negative 90, negative 135, I would end right here. But something I want you guys to notice every time is wherever this point is, reflect it, follow it straight down, and that will always be the negative angle. So if you are looking at this and you're like, oh, I hate the negative angles, look at just the positive degree angle and then reflect it down across, straight down, and you will find the negative angle similar. So that will work every time. Every time, I promise you. So we're looking down here actually at negative root 2 over negative root 2 over 2. Oops. Sorry. Didn't mean to do that. So sine is negative. Hey, man, we didn't want to use yellow. Negative root 2 over 2. Cosine is the same thing. Both x and y are negative in quadrant 3. So tangent, I'm going to have negative root 2 over 2 times the reciprocal. You can see how those are both going to cancel out and give you 1. And now we can do our reciprocals. 2 over negative square root 2. That's going to give you 2 square root 2 over negative 2 or negative square root of 2. Since they were the exact same coordinate for sine and cosine, secant works out to be the same. It's just the negative square root of 2. And cotangent works out to being 1 because the reciprocal of 1 is just 1. So now I want you guys to pause this video, take a second, and see if you can get a scientific calculator and calculate all of these. Because 65 degrees is not a known value on our unit circle. Neither is 112. 360 is. You could do this one without, but you can also use a calculator. 10, negative 73, 227. Those are all oddball ones. So I want you to make sure your calculator is in degrees mode and go ahead and see if you can put these guys in there. I hope you notice that there's no secant, cosecant, cotangent buttons on there. So we're going to need to use how they're defined as the reciprocal functions to help us, and then we can use our calculator. So cosecant, that guy is the reciprocal of sine. So this is really 1 over sine of 65 degrees. And you can punch that in your calculator. Secant is 1 over cosine. It's the reciprocal of cosine. So we can do 1 over cosine to get these values. Cotangent, remember that was tangent's reciprocal. So this is 1 over the tangent button of 360 degrees. And then set all of these up. So secant is 1 over cosine of 227. Cotangent is 1 over tangent of 10 degrees. And cosecant is 1 over sine of negative 73 degrees. Now I want you guys to punch all of these into your calculators. Now, if you do not have a cool calculator, check it out. I've pulled up Desmos for y'all. We've got, all right, guess not. I don't know where it went. But we can pull it up real quick. It ain't no thing, chicken wang. So we'll go to desmos.com and we're going to pull up our scientific calculator, y'all. So you can do it on the graphing one, but honestly, it's a lot easier if you just go to Math Tools, scientific calculator. And then remember, we had cosecant of 65, which was the same as 1 over sine of 65. If this button is clicked on, that means we're in degrees mode, and so we get 1.103 or 1.10. The next one we had was secant of 112, or 1 over cosine of, 112, and that will give you negative 2.67 if you round that appropriately. We also had cotangent of 360 degrees. That's 1 over tangent of 360 degrees. And that's going to be undefined. You know why? Because tangent of 360 is 0. 0 over 1, that's 0. And 1 over 0, we can't have that. That is undefined. Never, ever, ever divide by 0. The next one we had secant of 227. That's 1 over cosine of 227 degrees. That gives you negative 1.47 approximately. We had cotangent. That's going to be 1 over tangent of a whopping 10 degrees. And we'll get 5.67 as our solution. And lastly, we had cosecant, or that's 1 over sine of negative 73 degrees. You can literally type it in your calculator just like that, or Desmos, and you'll get negative 1.045 or negative 1.05 if you round up to 2 decimal places. Now, if you're not convinced, all right, to figure out like negative 73 degrees, what that is for a positive, you're going to take 363, take away 73, and that gives you 287 degrees. 287 degrees and negative 73 are coterminal. They're the exact same angle measure. So I could also do 1 over sine, of 287 degrees. And notice that I get the same answer here and here. So that's how you know that we did it correctly. So let me punch all of these bad boys onto here. Luckily, I had, excuse me, sir, written these down. So after using a calculator or Desmos, I mean, honestly, Desmos is pretty easy. This one was 1.10. Secant was negative 2.69. Make sure you can get these in your calculator. This guy was really 1 over 0, and that was undefined. Excuse me, this cough is so gross. I apologize. Secant of 227 was 1 over cosine 227. That's negative 1.47. Rounded. This one was about 5.67 rounded, I believe, and this was negative 1.045 or so. So make sure you can punch that into your calculator. If you're not sure how to convert between degrees and radians, just use Desmos. It's so easy. Also, next time I'm in the classroom, let me know and I'll help you out with it. Figure out how your calculator works. For some of you, you need to type in the input, whatever's in the parentheses first before you hit your function. If you're using like your iPhone, you'll have to put 1 divided by 360 and then the tangent button and then hit the equal sign. If you have a calculator where you can watch, like see what you're inputting in, like Desmos, you can just type it exactly as it is and it will calculate it for you. Here is some function notation. Let you guys pause the video, try it out, and we'll come back with the solutions on this guy real quick. Pi over 6, that is 30 degrees. So f of pi over 6, that means cosine of pi over 6. If you look at your unit circle for pi over 6, the cosine coordinate is rad 3 over 2. I'm going to just work down on the f functions first because they're all defined as cosine of that angle. 240 degrees, that is in quadrant 3. F of 240, that means the cosine of 240, looking at my unit circle, that's negative 1/2. And pi, so I want cosine of pi. Pi is the 180 degrees, that's negative 1. The next one, G of x is defined to be sine of theta. So I'm going to work downwards. 135, that is in quadrant 2. That's a 45-degree angle, reference angle. So that means we got root 2 over 2, root 2 over 2. X is negative over here. And sine is the y coordinate this time. So this is going to be positive root 2 over 2 from our unit circle. 5 pi over 3, y'all. 5 pi over 3, that's in quadrant 4. The sine, which is the y, remember it goes cosine comma sine, was negative rad 3 over 2. And 390, this one's kind of tricky if you think about it. So this is 360 plus 30 more is 390. That's the same thing as 30 degrees. 390 is the same thing as 30 degrees. So sine, cosine comma sine, that's positive 1/2, the y coordinate. Then we have h. H is tangent of all of these angles. So tangent of 45 degrees, that's in quadrant 1. That's root 2 over 2, root 2 over 2. You end up with this, and you get just 1. 120 degrees. I want to find tangent of 120. That is in quadrant 2. We have the sine coordinate, or the y, is rad 3 over 2. Keep it, change it to multiplication, and flip the cosine. That's going to be 2 over negative 1. And you get negative square root of 3 for h of 120. And h of negative pi over 4 means instead of going up 45 degrees, we're going to go down 45 degrees. That puts us in quadrant 4 at 7 pi over 4. That's the same thing. And we're going to have negative root 2 over 2 divided by root 2 over 2, or keep, change, flip. Looking at our unit circle, I don't have it anymore on this screen, but you guys do. I know you do. And so we'll reduce that to negative 1. This one was kind of a slight challenge because you just needed to know that we had to look at what is F and G and H. But really, it looks scarier than it is. So all of the F functions, all of these that said F, 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 we just needed to evaluate cosine of pi over 6, cosine of 240, cosine of pi. For everything that had G in it, we needed sine of that particular angle. So sine of 135, sine of 5 pi over 3, sine of 390. And lastly, h was tangent function. So we needed tangent of 45, tangent of 120, tangent of negative pi over 4 to determine these output values. Remember, way back in the day, we said that this part right here was the input, and basically you can think of it as your x value, and what you get out is the output, or the y. And so all of these pieces right here, those were the outputs. When you plugged in those angle measures for the inputs, this is the values we get for our outputs. And lastly, slightly harder problem. Evaluate the following using function notation. So I'm giving you a ton of different angle measures. I'm giving you 0, pi over 2, pi, 3 pi over 2, or 2 pi. We're really just going around the unit circle here. Going all the way around. 0, pi over 2, pi, 3 pi over 2, 2 pi. We're just going around the unit circle for that matter. And we have to plug it in to this function, okay? This is where it gets kind of tricky. Cosine of x take away pi. But notice all of the angles are marked as x, right? They're all marked as x. So we're quite literally going to plug this in. So when I plug in x is equal to 0, I get f of 0. When I plug x in for 0, I get cosine of 0 take away pi, right? Everywhere there was an x, I'm going to plug in 0. That gets me cosine of negative pi, which on the unit circle, instead of positive pi, we're going to go this way, negative pi. We end up at the same spot. That coordinate is x is negative 1, y is 0. And remember, cosine is the x coordinate, so that guy is just negative 1. When I go to plug in pi over 2, when I plug in pi over 2 for x, that's what this f of pi over 2 means. It means I'm going to have cosine of pi over 2 take away pi. In order to actually do what is inside these parentheses, you need a common denominator. So to do that, we're going to multiply pi by 2 over 2. You get cosine of pi over 2 minus 2 pi over 2. And if you do take 1 pi and subtract off 2, you get, cosine of negative pi over 2, which is going to put us right down here. And that coordinate is 0, negative 1. And cosine is the y value, so that actually gives us 0. To plug in pi, we're going to have f of pi is equal to cosine. And everywhere there was an x, we're plugging in this value, pi. Pi take away pi. Well, if you had pi and you took away another pi, you have nothing. Cosine of 0. That's this point right here. This quadrantal point right here, which x is 1, y is 0. So we get 1 again. 3 pi over 2, we're going to need a common denominator for this one, but we'll continue on the pattern. We are plugging in, 3 pi over 2 for x. That means we're going to have cosine of 3 pi over 2 minus pi. And if I just get a common denominator, you multiply this by 2 over 2, voila, we're here. 3, and now we can just work with the numerators. 3 take away 2 is 1, so you're left with cosine of just pi over 2. That is up here. X is 0. For that coordinate. I don't know why it's not drawing. X is 0. Y is 1. So that gives us back at 0 because cosine is the x coordinate. And when we plug in 2 pi, what do we get out? We get cosine of 2 pi take away pi. That gives just cosine of pi, which means we are back over here at that spot. Remember, cosine gave us negative 1 for that guy. All right. That's it for this video. Catch me in the next one. Thanks so much.